Hi, I'm Mohammed Arif, and I'm here to present on the Internet of Things as my assignment. Straight away, we're going to go to the first question, which are the major challenges. So the few ones that I find especially prominent is, first of all, lack of encryption, or more generally, lack of security, is usually due to resources constraints and conflict of interest. It usually stems because of the nature of the embedded processors, because developers usually design those processors to be as small and as um, resources efficient as possible, so it uses the least amount of resources. Next, we have lack of standardization. Different manufacturers uses different protocols, which induces low interoperability. So next, we have big markets. The two that I find significant are smart home, such as Google Home or Amazon Echo. For it is it is designed for consumers for convenience and automation, whereas there are also IoT uses in industrial scenarios for predictive maintenance, quality control, and automation, where they're used usually alongside AI and robotics to cut costs in businesses. Impacts and applications. Again, on the consumer level, it improves efficiency, convenience, safety, and sustainability. And for businesses, it usually provides economic growth due to cutting costs. Basically, it's lastly, we have ethical concerns. The two that I find that are most significant, which is privacy and security. Obviously, IoT uses data, asks for data, but even with consent, we don't really know where that data is going to. So any scenario where data is shared by the user, um, it will raise privacy concerns regardless. And of course, security, it ties back to the major challenges where encryption is usually not applied to these processors and IoT technologies, so it can be hacked, risking personal and societal harm. Lastly, environmental impact. Of course, IoT technology involve devices that are similar to either other technologies. It has short lifespans and usually are not designed to be recyclable. ESPI. So, for the internet clock, it's fairly simple because you just use one of the examples given by the ESP32 libraries, the TFT SPI modules, which is that part pretty much already does the most of the work for you in displaying the analog clock on the TTGo display, which I will show in this moment. But what I did on top of that to ensure accuracy. So what you do is just include the necessary libraries, Wi-Fi.h and time.h, connect to the internet. This is declarations, pointers for all the necessary requirements. Um, what is interesting is you have to, um, for our time, we have to daylight savings. So we need to move 1 hour. This is the basically UTC plus watts. So this is 1 hour, 3600 seconds. And then you just apply here, connecting to the Wi-Fi, config time. This is the important line where you can connect to the NTP server, like after connect to Wi-Fi and get local time, where this function will get the time from the NTP server. And then this is all code from the library to display the clock. And we replace the original function to emulate the clock function to move seconds, of course. And we just, instead of that, we just replace it with the get local time function. We call the get local time function to get the time from the NTP server instead. And that's all. Here's the serial monitor showing the current time, and I can show you the actual board actually here. Hold on. If I can show you, there it is. Yep, it's 135. 135. Yes, probably 136 now. You can see in the serial monitor. Yep, 136. There you go. That's all for me. Thank you.